Howdy folks, today we're looking at the flathead engine design used in early Mopar cars. When I say Mopar, I'm referring to Chrysler, Plymouth, DeSoto, Dodge, and Imperial, the Mopar lineup. What we have on the floor here is the original engine from this 1938 Plymouth Deluxe. It is a four-door sedan. In 1938, this engine is a 23-inch long block 201 cubic inch engine. It's a Canadian built car, but at that time these engines were 23-inch long engines, which might have been made in the USA. So same engine used in the American and Canadian cars in 38 for this car. This car was assigned an engineering code by the engineers at Chrysler. This is a model P6 car, and it's got the flathead engine in today. We're going to primarily talk about the flathead engine. Simple design. This is a video for beginners to learn about flathead engines, a few little interesting things about them. I've got a couple of reference materials here. We've got the original shop manual for this car, which is the P6 here, which is the Deluxe. The P5 was the Road King model. I think had a little less features on it. And we've got a book here called Dyke's Automobile and Gasoline Engine Encyclopedia. It's a thick book, and it is awesome. I highly recommend it. They put one out, I think, about every year. This is the 20th edition. It's dated about 1940 or so, around that era. And I'm going to reference a couple of images in this book just for education of what I'm showing you here. Also, as a reference material over here, we have my 1953 Chrysler. It's my other car, drive it regularly, and I'm going to reference a few things on this car as well. So let's get back to this engine here. We talked about the P6 engineering code on the car. If we go over to the block, this is the front of the engine over here. If you're looking in your car, in this corner here, this is a cast block. After it was cast, they stamped in a serial number on the block. Here we've got P6 103653. That P6 stamping tells me that this is an original engine from a 1938 Plymouth Deluxe, because it's a P6. It's original engine. Down here, we got a date stamp, 11/3/37. Late in 1937, November 3rd, this block was cast, and it would have went through production, been assembled, and gone into a car that was dated as a 1938. Likely the car right behind me, more than likely. I bought this car a few months ago, and it came with the original engine here, because it has currently a 1954 228 cubic inch engine in it, because this one, I don't know, I guess it was worn out. That engine was swapped in about the 60s, mid-60s. So let's just say that this engine saw 30 years worth of life in the car. Then the owner plunked in a newer engine from 54. This is the serial number of the block here. They mean something to somebody. I'm not sure exactly what they mean, but so this is a flathead engine. Let's get into that. I'll tell you why. Cylinder head is off. The engine's somewhat disassembled. This is how it came to me. The pistons have been removed. Here's your valves here, and valves are all in the block. The cylinder head on the floor here, you can see, very basic. There are no moving parts in it, and it basically sits flat. So we call it a flathead. Somebody came up with that saying. The engineers of the time, they called it an L-head design, and I think flathead is more slang, local lingo talk, and makes sense. It's flat. The cylinder head has no moving parts. This is where the spark plugs thread in. They are not evenly spaced over the center of the head. You'll see why shortly. It is cast, and it is hollow inside in sections to allow engine coolant to flow through around and cool the cylinder head. Let's flip this block, the cylinder head over here, and you can see a unique, interesting combustion chamber. This is flat here, and it's ramped upwards to this area, which is cut out a deeper dish area here. You see the difference there in the spark plug hole is here. It's not centered, which is interesting. This area right here would be the combustion chamber. when you look at a piston in one of these engines, the piston comes all the way up, right almost to the top of the block here. The piston travels up. So the explosion is not happening directly over top of the piston. It's offset over to the spark plug area. This is your combustion chamber here. This is a ramp here. So it's interesting. I looked at that and I wondered why. Because you can lay the cylinder head on the engine. Here's your cylinder and your piston over here. And that ramp, picture that ramp coming up like this, and the combustion chamber is over here, kind of in this area. Spark plug is, I believe, over the intake valve area, which must help with burning the fuel. So I kind of wondered, why would the explosion not take place directly over top of the cylinder area? Because if you had an explosion here, that would give you the biggest bang for your buck and push the piston down, is what I would think. But I'm no engineer, and they did a bunch of studies and found out that by moving, and this engine design, this style of engine, which is called an L head, I mentioned earlier, the valves are all in the block here. Both intake and exhaust valves are in the block. And if you look at, I suppose, airflow, maybe, you get your piston traveling up and down here, and then the airflow goes this way, either in or out, the intake exhaust. That gives you an L shape, like that. So I did a little research on this interesting combustion chamber design, and I was reading in my my book here from Mr. Dyke, A.L. Dyke. I learned about the Ricardo cylinder head. Mr. Ricardo was an engineer in England. He did a bunch of work with tanks and boats and automobiles as well. And you can see this is a great illustration here of the piston coming up to the top of the cylinder and forcing the air-fuel mixture up this little ramp area here and forcing it over above the valves. That would be your combustion chamber over here. But see little arrows and little specks. That's illustrating the flow, how the air-fuel mixture becomes very turbulent. As it's spinning and moving violently, it allows better combustion. You get a full, thorough burn that's violent and fast, and you actually gain, I think Mr. Ricardo said he proved that between 8 and 12% improved combustion with his cylinder head design. Chrysler used it. Others did as well. There are a couple different designs of cylinder head combustion chambers, but this is the one that Chrysler's using, and it worked for them. So it's interesting. Mr. Ricardo deserves credit for that. Getting back to our engine. So talking about Flathead's inefficiencies, these engines worked well for their day. We just talked about an improvement in cylinder head design and combustion chamber design. But if we think about the air, fuel coming in through the carburetor, down through the intake and exhaust, intake manifold, and into the engine, and then down into the cylinder. We've got a carburetor sitting over here. Let's picture a downdraft carburetor sucking air and fuel together, throwing it into this port right here. This is an intake port. Intake manifold comes here. The air fuel mixture comes in here, goes up the valve. This valve will be open. The way this engine is sitting right now, it's not timed properly, but this would be open for the intake stroke. Air fuel mixture goes in here, this valve opens. It goes through this valve, so that's what? A 90-degree turn up, another 90-degree turn across the valve, another 90-degree turn down into the cylinder. The piston is moving down, sucking in, creating a vacuum, sucking in this air-fuel mixture. Piston gets to the bottom. Both valves are closed at this point, like this one right here. Both valves are closed. Piston comes up and compresses that air-fuel mixture, forces it into the combustion chamber. A spark plug ignites it, it explodes. That forces the piston down. When it's down, this exhaust valve opens up just at the right time. The piston comes up and pushes the airflow down through this valve area. So it's coming up, take another 90 down, another 90 out, then out the exhaust manifold. That's a lot of directional changes for an air-fuel mixture. So the engine wasn't all that efficient. It made power, but we get much more power today out of a similar displacement engine because of the engine design and improvements. They hadn't gotten there yet. They were doing a great job back in the 1900s, early 1900s with engines, but engineers just kept at it and kept improving all the time, and we ended up with like overhead valve engines with both intake and exhaust valves in the head, which allowed for quicker, more efficient intake and exhaust of our air-fuel mixture, making more horsepower. So this particular engine is designed for lower RPM. It made pretty good torque. Torque is kind of lower RPM power to pull something, to pull a heavy load under, like climbing a hill. So this particular engine, if you had a longer stroke here, you get a lower revving engine because of the travel of the piston inside the cylinder here, but the long travel gives you more torque. So these engines were pretty torquey for what they were compared to in their day. They were decent. But one thing I want to point out is you've got your valves here in the block. There were different types of arrangements here. You had a flathead style that had, was it called a T engine? You had an intake valve on one side, an exhaust valve on the other, and then the cylinder head bolted on top. That's a T style. This is an L head. We talked about that. Both valves on the same side. And then you had an F head, which had an intake valve on the top in the head. And that would not be a flathead because it has moving parts in the head. And then you had an exhaust valve on the side like this. And there's an I head as well, I believe. And I think that had intake and exhaust valves overhead, I think. So these intake and exhaust valves are not exactly the same on every cylinder here. You've got exhaust, intake, and you've got intake, exhaust, exhaust, intake, intake, exhaust. They're mixed up, and there's a reason for that. They don't have to be in order. I'll show you why. I'll go over and look at my 1953 Chrysler here, and I'll show you a manifold installed on a flathead engine. This engine is a little bit bigger. It's 265 cubic inch. It's a 25-inch long engine. And if you look, this is our intake manifold here. And our exhaust manifold is silver. See how we've got exhaust here? There's two here exhaust. There's two exhaust ports over here and one at the back. So I got 1, 2, 3, 4, 5, 6. Every exhaust valve gets its own manifold section. All comes out here at the rear of the manifold, out the muffler. Exhaust pipe here. Intake is black. We got one here, one straight in behind here, and one towards the front here. There's only 3 legs in this intake manifold. It's because every cylinder on the intake, every port in the manifold is shared with 2 cylinders. It's designed that way so that the intake and exhaust manifolds can bolt together nicely, take up less space. And also we use the exhaust manifold gases in this particular engine. When it's cold, this valve is closed, open, and forces exhaust gases up inside this area and warms up the air-fuel mixture. After it goes through the carburetor, comes down this way, it gets warmed up by the exhaust gases and then into the cylinders. And that helps atomize the fuel, make it into a nice fine, misty, fog type a gas, and allows it to combust and burn cleaner, faster, better. We don't get wasted fuel. So that's your intake and exhaust manifold. On this flathead engine, behind here is your valves. This is your valve surface here. The valve's got a long body that comes down and drops into this area. So this is your valve cover. And this particular engine came out after 30 years of service. You can see it looks pretty greasy in there. It looks like a heavy grease. That's from the type of oil they used in those days. It was called a non-detergent oil. The engine oil was designed at that time to trap unburnt gases and soot and trap it in the oil. However, when the engine was shut off and the car was parked and the engine cooled, all these trapped particles of soot and sediment would settle down and drip all the way down and fall into the bottom of your oil pan down here, sit here. Any low-lying areas in the engine inside, really. And there are pockets here. And this whole area you can see is covered in a greasy paste. It's like it's like bearing grease is what it feels like. We're calling that sludge. And as the engine is used over years and years and years, sludge does build up. Even if you change your oil, you're still going to get sludge buildup. Now, if you buy one of these cars and you want to decide, well, what kind of engine oil am I going to run in this car? You can't just go and buy a modern detergent-based oil and put in here like this. A modern detergent-based oil is designed to take all the soot and gases and things that are floating around in your crankcase and hold it in the oil and suspend it there and leave it there for the entire life of the oil. That's what it's designed to do. So it doesn't settle down and sink into the bottom of your oil pan and settle on all these parts here. You don't get this sludge buildup. So if you're taking an engine like this that has lots of sludge buildup, you don't know that it's in there, and you start putting a detergent oil in there, the detergent oil, a modern detergent oil, is going to break this down and try and suspend it in the oil. And what will happen is it'll overpower the oil. There'll be so much sludge breaking off of here and breaking down and getting the oil. It'll thicken up your oil, and you got all these pieces floating around now. It's going to probably plug up your oil filter. It could plug up oil lubrication orifices inside your engine. It's going to pick it up. Remember, there's going to be a bunch of it down here in the bottom of the oil pan. It's going to try and pick that up, and you could really lose your engine. You could actually have a oil lubrication problem and a seizure. So you're not going to want to do that. If you're going to want to run a modern detergent type oil, which is a good oil, you've got to clean all this out first. You take your oil pan off, you scrape it out, you clean it up, you spray and clean and brush all the sludge off the inside of this engine, and it's going to go down in the crankcase here. You got to get it all out. Once it's clean, then you can run a modern detergent type oil. Looking at what you've got here is your valve body, or your valve is at the top. The stem comes down, and there's the bottom of it. And you got your return springs. The valve ends right about here, and then you've got a tappet. This is called a tappet. It's adjustable. It's got threads on it, 2 nuts, and this is your tappet here. And it goes down, and it rides. The camshaft is down inside the block. And this is where you adjust your valves. I'm not going to talk about valve adjustments today. That's in another video that I've done. So, summarize. Don't run modern detergent oils unless you clean your engine out in these old engines. All right, so let's talk about cooling. I think this is a good point to discuss. On these old engines, let's go back over to my 53 Chrysler and look at the radiator and the cooling system. Okay, our radiator is here, the front. This is the flow from the engine to the top of the radiator. You get the hot coolant from your engine here. It travels down through your radiator. Air is pulled across the radiator and through it by the fan and when you're driving. And the coolant comes up this hose and into the water pump area right here, and then it's forced inside the engine. In those, I talked about hollow areas that are inside the cylinder head, coolant goes in there. You've got to have good hoses, a radiator that flows nicely, it's not partially blocked, and a good water pump that's moving all the coolant quickly and efficiently. But there's something that can still go wrong. You might have replaced your radiator, replaced your water pump, but you're still overheating. On these old Chrysler engines, I'm going to show you what might be going on, why it could be overheating. So here we've got the water pump mounting here. We showed that on the engine there. Water comes out of the water pump and goes into these 2 passages here. This one goes in around, it's hollow and goes into the block and travels down the block, down to about this area down here, and cools the cylinders. They're hot. This is actually a drain valve right here for the coolant in the block. If you're going to do a bunch of work, you want to drain your coolant out of your block, you open that up and it flows out. These are called Welsh plugs. They're expansion plugs because there's coolant in the block here. If you don't run proper antifreeze and you run water, in the wintertime, that water will freeze and ice expands. We're hoping that that plug is going to pop out and allow the ice to expand and sacrifice your block so it doesn't crack. That's why you have these all in the sides of the block here. So, Cylinder head is hot. You got exhaust gases coming out of the engine here. Your exhaust valves get really hot. All the valves do, actually, especially the exhaust valve. And we've got to keep these valves cool. You think about the coolant coming in the front of the engine here, and there's a hole right here, and the coolant comes in, it travels in around all these valves down inside the block, but by the time it gets back here, it's already pretty hot, right? It's getting hotter and hotter and hotter. It travels through, it takes the path of least resistance and goes down through, but way back here, these two cylinders are going to tend to run a little bit hotter than the front. And I don't want to get too much into setting the valves today. However, it's best to set the valves when the engine is hot. Chrysler recommends that you set the valves while the engine is running. That's possible. I've done it. There's another video on that. And the reason is these valves run at different temperatures. This one will be cooler than these at the back, and for reasons I just told you. This one will be a little hotter than maybe the front two. So we're setting them while they're hot because they run at different temperatures. So the water comes in here, but it gets hotter. By the time it gets to the back, it's not cooling that great. So the Chrysler engineers, I think, I don't know who came up with this, insert what's called a water distribution tube inside, slides in, the coolant goes in this end, and you can see little holes. There are 1, 2, 3, there are 6 holes that forces the coolant to come out near the exhaust valve. Now this one is in impeccably good shape. Might have been replaced once already, I don't know. But usually these come out looking like they came from the bottom of the Titanic. They don't want to come out. They're rusted terribly. And you're picking pieces apart and trying to pull them apart and drilling holes, and it's a mess. This particular water distribution tube is in very good condition. It's a miracle that it came out in one piece. I was impressed. So that again is redistributing water properly and keeping your engine valves especially cool. That's important. So if you have an engine that's overheating and you can't seem to figure out why, you're going to have to look at that water distribution tube and keep your fingers crossed that it comes out in one piece. So that kind of is a high level discussion around the Flathead and how it works. Some cooling. We talked about the oil inside there and what you should do there. We talked about directional changes of air-fuel mixture. I'm hoping this has been valuable to you guys. Cylinder head design. This is your port for your oil fill. Comes up the side of the engine. There's a tube there and you're pouring oil in, goes down to your crankcase. This is where your distributor goes in. It's driven off the camshaft. This is your oil relief for oil pressures in here. The main oil pump is on the other side of the engine. And you set your pressure here with springs and shims. Your main oil gallery runs down inside the engine here and feeds pressure-fed lubrication to the main and connecting rod bearings. There is a access port here to the main oil gallery. It's into your crankshaft here. A couple more expansion joints or plugs. I think that's about all we're going to get into today. There's your oil pump right here. Camshaft is down inside here. Oil pump is gear driven off the camshaft. And right here is where your fuel pump mounts. It sits here and there's an arm that goes in and it travels up and down on a cam lobe. And it's a diaphragm type pump and it allows fuel to burn. You kind of see some light in there. Part of the crank you can see, and the camshaft is just below it, just here in this area. So your camshaft's right about there. All right, I hope you learned something today. This is a beginner's introduction to Mopar flathead engines. This is the 1938 201 cubic inch engine. Have a good one.